Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one circle diagram lost more marks than any other on last year's papers, and the reason wasn't complicated. Students forgot to write why their angles were equal. Imagine sitting the paper and knowing the angle, but losing 2 marks because you didn't label the chord or state angle in the same segment. Sounds harsh. It happens all the time. Today, I'll show you a single reliable theorem that turns confusing circle diagrams into routine marks. The concept starts simple. We focus on 2 closely linked facts you must master. Fact 1. Angles subtended by the same chord are equal. Say you have a chord AB on a circle and 2 points C and D on the circumference. The angle ACB equals the angle ADB. Both are subtended by the same chord AB. Say that out loud when you see it. Same chord, same angle. It helps you spot equals quickly.
Why does that work? Picture triangle AOB, where O is the center. The central angle subtended by AB is twice any angle on the circumference subtended by AB. You don't need to memorize the central angle proof for every question, but know this. Both angles see the same chord under the same arc, so they match. If it helps, sketch identical tick marks on the arc and say same arc, same angle.
Fact 2. Equally important. Opposite angles in a cyclic quadrilateral add to 180 degrees. If ABCD lies on a circle, then angle A plus angle C equals 180, and angle B plus angle D equals 180. A quick reason. 2 angles subtended by supplementary arcs must sum to a straight angle. Practically, this means if you know one angle in a cyclic 4-sided shape, the opposite angle is 180 minus that angle.
Let's work through 2 short examples step by step. Example 1. Chord AB, points C and D on the circle. Angle ACB is 42 degrees. What is angle ADB? Recognize both angles subtend chord AB, so mark them equal immediately. Angle ADB equals 42 degrees. That's it. But write it down. Angle ADB equals angle ACB equals 42 degrees, angle in the same segment. That sentence is your method. Examiners love it.
Example 2. ABCD is a cyclic quadrilateral. You're told angle A equals 110 degrees and asked for angle C. Use the cyclic rule. Angle A plus angle C equals 180. So angle C equals 180 minus 110 equals 70 degrees. Write the algebra. C equals 180 minus A equals 70. Again, write the reason. Opposite angles in a cyclic quadrilateral sum to 180. That's the key phrase to earn the method mark. A quick note on labeling. When you see a chord or a quadrilateral, put small letters on the diagram. Label the chord AB, put tiny angle flags or curved arcs with the degree you know. Visual marks help the examiner see your method at a glance. Don't just do the arithmetic in your head. Write it down, don't just think it. The exam technique. Here's where the marks are. Most angle questions are 2 or 3 marks. Typical 3-mark layout. M1 for identifying equal angles or writing the equation. M1 for carrying out the substitution or simple algebra, A1 for the final answer. Example, if you write angle ADB equals angle ACB, that's M1. If you compute 180 minus 110 equals 70, that's another M1. The numeric answer, 70 degrees, is A1. Here's the practical takeaway. Aim to record each method step on the paper. Even if you miscalculate, method marks can still save you. A common slip that costs marks, not giving a reason. Students write a numeric answer but never state angle in the same segment or cyclic quadrilateral or show the equation that led there. Examiners can't read your mind. A tiny sentence naming the theorem turns a guessed number into a marked method. Another losable error is mixing up which angles subtend which chord. Label the chord and draw small arcs to show the subtended arc.
The Quick Win, a 10-second checklist you can use in the exam and in practice. Ready? Tick these off. 1. Label the chords. Write AB on the chord. 2. Mark equal angles with small arc marks or an equal sign. 3. Write the short reason, angle in the same segment, or cyclic quad, opposite angles sum to 180. 4. Do the arithmetic and box the final answer. 5. Quick check. Does your answer fit the diagram? If opposite angles, do they sum to 180? If they should be equal, check both of the same number. Don't skip the check. It catches most silly slips.
Do this every time and you'll convert guesswork into method marks. Write it down. Don't just think it. Let that sink in.
Rapid practice. Time for a quick lifestyle question. I'll read it, pause for you to think for about 12 seconds, then I'll talk through the answer. Question. In circle centre O, ABCD is a cyclic quadrilateral. Angle ABC is 64 degrees. Find angle ADC. Pause now and think how you'd label the diagram. Right, answer time. If ABCD is cyclic, angle ABC and angle ADC are opposite angles, so they sum to 180. So angle ADC equals 180 minus 64 equals 116 degrees. What would you write on the paper? I would write ADC equals 180 minus ABC equals 180 minus 64 equals 116 degrees. Cyclic quadrilateral, so opposite angles sum to 180. That gets both method marks and the accuracy mark. Marks are there for the taking.
One more short variation. If instead you were told angle ACB is 48 and asked for angle ADB, where both subtend chord AB, write ADB equals ACB equals 48 degrees, angle in same segment. Simple sentence, immediate mark. Same method, different numbers.
Outro and call to action. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a downloadable diagram sheet with labelled examples and practice questions at jcacademyonline.co.uk. Visit the show notes for the practice pack and a one-page checklist you can print and stick to your desk. Stay curious, trust the process, and nail that exam.